Okay, so we're going to take some notes about ionic compounds and what they are, the types of ionic compounds, and how they're formed. So to start, let's remember that ionic compounds are those that are formed between a cation and an anion. And remember, a cation is a positively charged ion, and an anion is a negatively charged ion. Okay? Now, typically, the cation is a metal, and the anion is a nonmetal. Okay? Now, there's two main types of ionic compounds. And the first one is called a binary ionic compound. Okay, binary ionic compound. So bi, the prefix bi means two, and so a binary ionic compound consists of two elements. And these two elements are a metal and a nonmetal. Okay, so those are binary ionic compounds. Examples might be NaCl or lithium chloride, Kf or potassium fluoride, okay, where there's two elements, one of them is a metal and the other one is a nonmetal. Another example might be magnesium chloride or MgCl2, where there's a metal and a nonmetal. This subscript here just tells us how many atoms of that element there are. Okay, so these are three examples of binary ionic compounds. The second type of ionic compounds are ionic compounds with polyatomic ions. So ionic compounds with polyatomic ions. Okay, so ionic compounds with polyatomic ions, before we can really answer what or explain what this is, well, it is exactly what it says is. It's an ionic compound with a polyatomic ion. So it consists of a cation and an anion, where one or both of these is a polyatomic ions. Okay, now we need to answer this question that is probably burning in your mind. What is a polyatomic ion? A polyatomic ion is an ion that has more than one element or more than one atom. Polyatomic ion is an ion that has more than one atom. Okay, so if you think about this, the prefix poly means many, and then the Greek root atomos means atom, and so when you put them together, it literally means many atoms. Okay, so a polyatomic ion is just an ion that has many atoms. Some examples, an example of this, okay, an example of this might be NH4+. This is the symbol for the polyatomic ion called ammonium. Okay, ammonium. Okay, notice there's more than one element here too. There's nitrogen and hydrogen. Okay, and it's an ion because it has an electrical charge on it. In this atom, this subscript tells me that there are 4 hydrogens. And since there's no subscript here next to the nitrogen, I know that there's just 1 nitrogen. So when I add that together, this one single ion has 5 atoms in it. But it behaves, so polyatomic ions, they behave as a single unit. So it acts like a single unit, or a single atom almost. Some more examples of polyatomic ions would be CO3 2-, which is carbonate, which has 4 atoms. There's SO4 2-, which is sulfate, which has 5 atoms. There's also SO3 2-. Yeah, that's right. SO3 2-, and this is sulfite. Okay. And that has 4 atoms. Another big one is OH-, which is hydroxide. And this only has 2 atoms. You have a polyatomic ion reference sheet. That you need to have to help you reference polyatomic ions. One last note about polyatomic ions. Notice that most of them, not all of them obviously, but most of them end with either ate or an ite ending. Okay, so they have an ate or an ite ending. So this can help you kind of make a distinction between a polyatomic ion or an ion that is just an element. Okay, so I guess that's pretty much it. So right now I'd like you to pause the video and I'd like you to go to the pair deck and do slide number 2.